Okay, so the last bit is called transformations of roots, linear transformations of roots. And that's when you've got an equation with one set of roots, in this case alpha, beta, gamma, and you want to find an equation which has related roots, but a different equation. So this new equation that we want to find, it's got roots 2 alpha, 2 beta, 2 gamma. So they're related to those, but not the same. Or for this one, alpha plus 3, beta plus 3, and gamma plus 3. So they're related to those roots, but they're not the same roots. So the first thing, the first way we could do it is by looking at the things that we already know. So we know that for this one, the sum of the roots, so alpha, so for this equation that we've got, alpha plus beta plus gamma is minus b over a. Alpha beta plus beta gamma plus gamma alpha is c over a, and alpha beta gamma is minus d over a. So we know these things. And then we can use those to work out the new equation. So I could say for the new equation, the sum of the roots for the new equation would be 2 alpha plus 2 beta plus 2 gamma. And for the new equation, which I'm trying to find, that would be minus b over a. Well, that is 2 lots of alpha plus beta plus gamma. Alpha plus beta plus gamma is 2. So I know that for this equation, the new one that we're trying to find, minus b over a is equal to 4. I could also look at this version of the roots for the new roots that I've got. So it would be 2 alpha, 2 beta, plus 2 beta, 2 gamma, plus 2 gamma, 2 alpha, and for the equation we're trying to find, that would be c over a. So you can see here that that's 4 alpha beta plus 4 beta gamma plus 4 gamma alpha, which is 4 lots of alpha beta plus beta gamma plus gamma alpha. This is 3, so it's 4 lots of 3, so 12 is c over a. So I'll be using that for my new equation. And then for the product version of it, I might fit one. It would be alpha plus, oh, I'm doing the wrong thing, sorry. It would be 2 alpha, 2 beta, 2 gamma, which would be minus d over a. So 8 alpha beta gamma is minus d over a. Alpha beta gamma is 4, so 8 times 4, so 32 is minus d over a. Right, there is no denominator in these, so if there were denominators here, you'd have to put them over a common denominator to work out a, but we don't have a denominator here, so we know that a is 1, which means that b, if a is 1, b is minus 4, c is 12, and d is minus 32. Which means for the equation that I want with these roots working backwards, I've got x cubed minus 4x squared plus 12x minus 32 equals 0. Okay. We could do it a different way. I quite like this way, but when you get to quartics and even for some cubics, it's not always very nice to do. So although this is the method that I would definitely use for quadratics, and for the simpler cubics I'd probably use this second method for anything that's more complicated, or anything where the transformation is more complicated, let's say. I might just do it. Trying to save paper, flapping around, look. Okay, so if I go back up to here then, now I could say, if I do it with method 2, the equation in x has roots alpha, beta, and gamma. And the equation in x with those roots is x cubed minus 2x squared plus 3x minus 4 equals 0. I want to find a new equation which is related to these but not the same. I'm going to call that equation in W. I'm only using W because that's what they use in the book. So if you did look at that email that I sent you out, it will have w's in, so we might as well stick to the same notation. The new roots are 2 alpha, 2 beta, and 2 gamma. How do I get from there to there? Well, w is 2x, which means that x is w over 2. And once I know what the substitution is, so I'm looking at how do I get from there to there? Well, w is 2 lots of x. I can then rearrange that for x to find the substitution and use that to find the related equation. So actually I'm not really using any of the results for the sum, product, etc. of the roots. So for this new equation with roots 2 alpha, 2 beta, 2 gamma, I know that it's w over 2 cubed, because x is w over 2, which we found out by looking at what's going on, minus 2 lots of w over 2 squared plus 3 w over 2 minus 4 equals 0. So w cubed over 8 minus 2w squared over 4 plus 3w over 2 minus 4 equals 0. I don't want these denominators, so if I times everything through by 8, I get w cubed minus 4w squared plus 12 minus 4 equals 0. Which is actually the same, oh, I folded it over now, as what I had here. And they both fit on the screen. There you go, exactly the same. Oh, I'm so stupid. I didn't times 4 by 8, sorry. Times it by 8 and you get 32. So they were nearly the same. They should have been the same. So exactly the same equation, it's just that this one we've done a substitution and ended up with a change of variable, which is fine because it's asking you to find an equation with those roots.